Hello, everybody. My name is James Petrowski, and I am an instructor here at UNLV. And I am the author of Assignment 9, which is our linked list assignment. So I'm here to explain to you how this assignment works, where you can find things in the PDF and in the code, and hopefully you can get started and have as little trouble with this assignment as possible. So, if you haven't guessed by now, we're doing the card game War, which I'm sure some of you have played before. If you have not, I will be explaining the rules. Anyway, before we move on to that, though, I will just let you know that this assignment will compile as a skeleton code. So all of the code that's given to you, you can just throw it on whatever environment you have, compile it, and you can even run it if you'd like. Though I do recommend that you make a testing main CPP file that is separate from all of the other files. And then you can kind of pull in that deck and card class that I'm going to be explaining later in this video. And kind of test those member functions out. And that will really help you understand the kind of mistakes that you might be making within those classes. Before you try to get the entire program working as a whole. So I would definitely recommend that. Though you're welcome to code this up in whatever method you would like. So let's just explain the rules of war very quickly. At the start of the game, two players are dealt an equal amount of cards. And in each hand, players will have the same amount of each weight of cards. And this is only at the beginning of the game. So this just means that each player will have two aces. They'll each have two kings, two queens, two jacks, two tens, two nines, all the way down to two. These piles of cards that were dealt out, there's 26 cards in each pile. They will be shuffled before we move on here to step 2. So then, once each player has their pile of 26 cards, shuffled pile of 26 cards, each player will turn over one card and add it to the pile. And so then here we're going to check. We're going to do a few if statements. If player 1's card has a higher weight, then player 1 will get to claim the pile and add that pile to their foot. And the foot is just a pile of cards that belongs to a player that are not in the player's hand. So if I'm playing war with somebody, I will have my hand, which is all the cards that I'm flipping over, and then I'll have a separate pile of cards on the table somewhere, and that will be my foot. And so whenever a player claims a pile of cards, they will add those cards to their foot, and not directly to their hand. So alternatively, if player 2 has a higher card, then player 2 will get to claim that pile of cards. And that pile of cards will only have the 2 cards in it that player 1 or player 2 had laid down initially. Unless, if each card that each player flipped over has the same weight, meaning player 1 flipped over a 9 and player 2 flipped over a 9, then the players will then add 3 cards each to the pile and then restart step 2. And we'll call this a duel. Okay, so what that looks like is player 1 flips over a 9, player 2 flips over a 9. Those 2 cards are put into the pile, and since they have the same value, then player 1 and player 2 will each add 3 cards to the pile. So now the pile has 8 cards. So then they'll come back up to step 2, and each player will then turn over another card. And so at this point, the pile will contain 10 cards. And we do this all again. If player 1 wins, they'll get all 10 of those cards. If player 2 wins, they'll get all 10 of those cards. And if they happen to be the same weight, then we restart the process. They each add 3 cards. So now it has the pile has 16 cards. And then they come back up to step 2. They'll then put 2 more cards in the pile. And so now the pile has 18 cards. And so on and so forth, okay? Luckily, this part is coded for you in main, but you're totally welcome to go take a look at it. It's all right here, and I'll kind of just point some stuff out. Notice here I initialize the deck. I'm adding cards to the deck: spade, heart, club, and diamond. And then each player has 2 hands. And so notice that I'm dealing them each a card from the deck. I then shuffle the 2 hands. I then give each player those 2 hands. I print them out just so I can see them before the game starts. I want to make sure that the cards are shuffled and that each player has an equal amount of equal weight cards, meaning 2 aces, 2 kings, 2 queens, so on. And then there's a pile where the players will place their cards. And then I do a bunch of if checks here. But if you come down far enough, you'll see that the cards will each turn 1 card over. They'll add them to the pile. And then we'll check to see if player 2 won, if player 1 won, or if it's a duel. And if it's a duel, the players will then add 3 cards, unless they don't have that many, to the pile. And then you'll see that the while loops kind of come to a close here. So go ahead and look at this while loop if you'd like, but this while loop is responsible for hosting the game. The last thing I mentioned here is if at any point a player has no more cards in their hand, they can shuffle their foot and add those cards to their hand. Okay, so if I run out of cards in my hand, I'll just shuffle my foot, pick it up, and now it's my hand. So the truth about this game is it could potentially go on forever if players keep alternating wins. So in this program, the game will always end in one of 3 ways. I don't want it to go on forever, and I'm sure our servers don't want it to go on forever as well. So one of the 3 ways that this game can end is one player will completely run out of cards by losing all of those cards to the other player. Which means player 1 has all the cards, player 2 has no cards, and the pile has no cards. The other way it can end is one player will deal all of their cards into the pile during a duel. And if this is the case, then the pile cannot be claimed. So player 1 will have some cards, player 2 will have no cards, and the pile will have the rest of the cards. And lastly, the players will just get bored after 1,000 turns. So you can kind of see I did a check for that in here. You'll see if num turns is greater than 1,000, then the players, they're going to get bored, and we're going to break out of this while loop. I've included sample outputs for all 3 of these cases, so go take a look at those to make sure that things are working. And obviously the decks will be represented as linked lists. So your job in this assignment is just to code up any portion that's interacting with the linked list in the deck. So there's 6 total files. There's card H and card CPP. This is where you're going to be coding. We've got player and player.cpp. We've got main.cpp, which I'm kind of showing you already. And we've got a make file to make compiling this assignment a lot easier. So let's go ahead and start talking about this card H and card CPP class, or files, rather. And we will be starting with the card class, because both the card and deck classes are contained within these files. And so I'm not going to spend too much time going over their kind of prototypes here. I'll just kind of show you where they exist. You can take a look. Here's the card, and then here's the deck class. And then if you come into card.cpp, here's all of the functions. Notice that I kind of gave you the outer part of each member function. So you can kind of just get going on those, and you don't even have to worry about putting the function header in here. I also give you this big UML so you can look at it if you want. But let's just talk about what we need to do. The default card constructor is just going to initialize both the suit and the value of the card to be this null character, which is \0. And the weight is going to be initialized to any negative value you want. And I suggest maybe -999. That's up to you. And the parameter constructor of the card will assign the suit parameter to the suit and the value parameter to the value. The weight will need to be initialized as well. And the weight is needed to determine which card has a higher weight. And so we have to do this because some of the card values are numbers, like 2, 3, 4, 5, 6, 7, 8, 9. And some of the card values are characters, such as ace, king, queen, jack, and then in this case we're doing T for 10. And so when you come into this file here and you look at these constructors, here's the default and here's the parameter, you'll initialize the suit and the value, and then you'll have to check the value in order to initialize then the weight. And the weight is here, of course. So the next thing you'll code is this string get card. This is equivalent to toString. It's just going to convert the card into a string and return it. That string will be space, pipe, bracket, suit value, bracket, pipe, space. So I give you some examples here. We've got the ace of spades, the 10 of clubs, and the 4 of hearts. So that's all you do for that one. The less than operator overload will be used in sorting the cards later on in the program. And so the way this works is the operator will first consider the ASCII value corresponding to the suit of the card. So a sorted list of suits will contain either the order of spade, heart, diamond, club, or club, diamond, heart, spade. If we're looking at the actual ASCII values of these characters, spade, S will have the highest ASCII value, and then HD, and then C. So if the suits happen to be the same, then the operator will look at the weight instead. And so first you'll check the suit, and then you'll check the weight. So I'll give you some examples here. Notice that the 2 of clubs is less than the 2 of spades, and that's because C is less than S. And then here we've got ace of diamonds is less than the 2 of hearts. And that's because D is less than H, even though A is a higher weight than 2, or A is a higher value than 2. And then lastly, if they are the same suit, in this case spade, we'll just go purely off the weight. So the 10 is less than the ace. And then I ask you to do the other operator. This is just the exact same thing as above, except backwards. So with some intuition, you can probably just do it in one line of code. Or you can just copy all of the code that's in here and put it in here and kind of reverse it, right? Lastly, you'll have the getWeight function, and that's just going to return the card's numeric weight. And you can see that this function gets called in main when I'm trying to determine which player has won. So you'll notice here C1 getWeight, C2 getWeight. Now we'll talk about the deck class. This is where the linked list is. Once again, you can take a look at this UML if you'd like. But we're going to kind of just jump right in here. So I ask you to notice the struct node that's within this class. So let's go take a look at it. Here it is. And so this is the linked list. This is how the linked list is, right? We've got a bunch of nodes that are linked to each other. And so we've got the node that contains some data, and that's the card. And then the node is going to point to the next node, right? And so whenever you want to allocate some new memory for the linked list, you're going to be using this node here. And you'll notice that the deck contains a pointer to the head of the linked list. The head will contain the node that contains the top card on the deck. Okay, so if the ace of spades is on top, then if we go look inside the head node, this card will be an ace of spades. And lastly, we've got the size of the deck here, right? So let's just talk about all of the member functions so you kind of know what you got to do. And notice that I describe these in a specific order. And I recommend that you complete them in this order because things like the bracket operator and the clear deck function can be used later on in the other functions, and that will really help you save some code, save some time. So the default deck constructor can just initialize head to be null, and the size of deck can be 0. So that's pretty easy. The clear deck function will deallocate the entire linked list and set the size of the deck to 0. Remember, if the head is already null, then there's nothing that you need to deallocate. The destructor also needs to deallocate the whole linked list. And it looks like we already did something like that in ClearDeck. So the destructor can just call this ClearDeck function unless you want to add more lines to your program. Now we'll look at the assignment operator. We have to do the assignment operator overload. And the reason for that is because this deck class contains a pointer. And so we have to abide by the rule of 3, in which we have to code a destructor, we have to code an assignment operator, and we have to code a copy constructor. Okay, so those things we're doing next. So consider the expression A is equal to B, where A and B are both decks, okay? So in this description, when I say the left-hand side deck, I'm referring to A, because it's on the left-hand side of the expression. And when I'm talking about the right-hand side deck, I'm talking about B, which is on the right-hand side of the expression. And notice the right-hand side deck is also the parameter deck that's passed into the operator. So if we go look at it in card.cpp, you will see it here. That is the right-hand side deck right there. So the first thing you need to do in this operator is deallocate the linked list on the left-hand side of the deck. Perhaps you can use ClearDeck. We already coded that, and that will make it easy for us to just deallocate that linked list real quick, no problem. And then the next thing you need to do is kind of copy the deck on the right-hand side, right? So the first thing you need to do is copy the size, and then you need to go through the right-hand side's deck linked list node by node. And for each node in the right-hand side linked list, you will need to allocate a node in the left-hand side linked list. Once a node is allocated and linked, copy that card within the right-hand side node into the left-hand side node. It's crucial that you do deep copies here, not shallow copies. If you do shallow copies, you will have significant problems in this program. And the reason for that is I'll show you in the player.cpp file. Notice that a player can swap their hand and foot. And so notice there are some assignment operators being called here. So if you start doing shallow copies, we're going to have some problems. I promise you. So make sure you do a deep copy. There's a few things we need to remember for this assignment operator. Remember that the head of the left-hand side will need to be pointing to the first node in the list. So don't forget to update the head node. Also, if the right-hand side deck is empty, then there's no copying that needs to be done. And lastly, ensure the last node of the left-hand side list is pointing to null or null pointers. So at the very end of that linked list, make sure you're looking at null. And that tells us when the linked list is done, right? The size of deck also tells us that, but this is good practice. Now you can move on to the copy constructor. And I promise you this one will be easily done with all the work that you did for the assignment operator. Okay? Recall the copy constructor will do the exact same thing that the assignment operator does, except the one difference is in the assignment operator, the linked list on the left-hand side will need to be deallocated, right? Because A was already declared, and then we're kind of overriding whatever was in that deck before. In this case, we're making a brand new deck, so we don't actually have to worry about deallocating the list. But chances are, if your clear deck is equipped to handle linked lists in which the head is already null and the linked list is empty, you might be able to just use the assignment operator in this copy constructor. But I'll leave that up to you. Just know that the code for these two things will be pretty much exactly the same. Next, we'll look at the bracket operator. And this operator will make life easy for us when it comes to sorting and printing the linked list, okay? So the job of the bracket is to return a pointer to a node within the linked list. So if we consider deck A again, A indexed at 0 would return the head, or the first node of the linked list within A. A43 would return the 44th node within the linked list. So all you have to do is iterate through the linked list an index amount of times, and index is the parameter that's passed into the operator. So let's go look at that. Just so I prove it to you, here it is. Notice the index. So all you have to do is kind of iterate through that linked list until you reach this index, and then you'll just return that node. You may want to verify that the index is within bounds, especially if you make some errors in your program. You can put some error handling to kind of tell you when you've got some problems going on here. The next thing you should do is the add to top of deck function. All this one will do is it will take a parameter card and it will add it to the top of the deck. So this just means you'll need to allocate a new node, copy the parameter card into the node, and then insert that node as the new head of the linked list, because it's like we're placing the card on top of the deck. And don't forget to increase your size. The next one you should do is remove top card, which will do the opposite. It will return the card that's stored within the head node, but it will also deallocate that head node and update the head node to be pointing at the next node in the linked list. So if I've got an ace of spades, and then I've got maybe a king of spades sitting on top of that ace, then remove top card will return the king of spades, and then it will deallocate the king of spades, and then the ace of spades will be the new head. And don't forget to lower the size. Don't forget to lower the size. Get size of deck will just return the size of the deck. Is empty returns true if size of deck is equal to 0. Or head is equal to null. Get random card index. I already did this one for you. All it does is it returns a random index for the linked list. So if the linked list contains 52 cards, this function has a chance to return anything between 0 and 51 inclusive. So it could return 51, 50, 49, 48, all the way through 0. But if the deck happens to only be 13 cards, then get random card index will return any index between 0 and 12 inclusive. And we use this get random card index to shuffle the deck because I would like to shuffle the deck randomly. Print deck, I already did it for you, but it goes through the list and prints the deck. So we'll go take a look at these real quick. Make sure your bracket operator is working, otherwise this function will not work. So let's go take a look. Let's see, here's add to top of deck, here's remove top card. Notice I'm returning a default card here. You should replace that. Here's clear deck. Notice I already did this getter for you. Here's is empty. Notice I already did that for you. Here's get random card index. Notice I already did that for you. In which we're just going to return a random integer mod the size of the deck. And then here's print deck. Notice that I am using the bracket operator on the this object, okay? So this bracket operator is being used to print out the cards very easily using a for loop. So if your bracket operator is not working, your print deck is probably not going to work either. So now it's time for the hard stuff. So now you need to work on swap cards, and you will be swapping the two nodes within the linked list. You must only change the next pointers within the node, okay? So if you have a linked list of nodes and you're going to be swapping two nodes in the list, you can only do it by updating the next pointers within the nodes. Once again, if we look in card.h, you can only update this item in the node. You are not allowed to swap these cards, okay? So you could just trade the data between the two nodes, but I'm telling you that you cannot do that. If you decide to just swap the card within the node, you will not receive full credit, though the program will work normally. So I'll just let you know that the program will look normal, and it will work as expected, but that does not mean you will get full points unless you only swap using the next pointers. Now there's an easy way and a hard way to accomplish this correctly. Consider using the bracket operator, which might help you. And please check with your instructor to see which method they would prefer, and if there will be point deductions or extra credit involved with the two different methods. Method 1, I call it the easy way. And so this swap card functions will only swap two nodes that are adjacent, which are right next to each other. This method is significantly easier than method 2 because the leftmost node is always the previous node to the rightmost node. So I kind of tell you what you need to do there. At most, you will update 3 next pointers. So you'll either update the left previous next or the head node. You'll update the left next, and you'll update the right next. And that will be enough to swap the nodes. Now, method 2, the hard way, says that the best swap card function would be a function that could swap any two nodes in the list, whether they are adjacent or not. So if you do it this way, you will need to find the node previous to the leftmost node and the node previous to the rightmost node. There's a bunch of things that you'll need to consider. And at most, you will update 4 pointers, which will be the left previous or head, the right previous, the left, and the right. But if the nodes are adjacent, like in the easy method, then you'll only need to update 3 pointers. So you're going to have to check for all of that. Your next thing that you'll be implementing is sort deck, in which you're going to sort the deck using the operator overload in the card class. Use whatever sort you would like, as long as it is not a library sort. The bracket operator will be very helpful here to access the nodes using for loops. Now keep in mind, if you did the easy method of swapping the cards, you should only use a sort that swaps adjacent nodes, such as bubble sort. Bubble sort will only swap nodes that are right next to each other. Or a sort that doesn't call swap cards at all. Leave that one up to you. So that's the sort cards, and then I think lastly here, that's the last thing, you'll have to shuffle the deck, okay? So here, I'll tell you how I did it. For a set amount of iterations, I say size of deck times 3. So if the size of deck is 50, then make a for loop for 150. And swap 2 random cards in the deck. So if you did the easy swap cards, then you'll probably just call get random index once. Gives you some random index in the deck. And you'll swap that node located at the index with either the node to its left or to its right, because they have to be adjacent. But if you implemented the hard swap cards, you can just call get random card index twice, and you might end up with a 0 and a 51, and you can just swap those 2 nodes. Player.h and player.cpp are done for you. Okay, you should be pretty easily understood. Just come in here and look at everything I did. I put comments in here. It's pretty obvious what's going on. None of the functions are more than, it looks like, 3 lines of code. So maybe 4 lines of code. Main CPP, I kind of already showed you. I say, how do you know your code works? Well, I would recommend making a testing main.cpp file to test out your decks before you try using it with the player class in main. I said in the YouTube video I will demonstrate this, so I'll go ahead and do that quickly. To compile your code, you can use make. You can use valgrind to check for memory leaks. And when you're done, you're going to submit your card.cpp file to Web Campus with a text file answering some comprehension questions. So I know that we probably haven't been doing these before, but just to make sure that we kind of know what's going on, I've asked you just 3 simple questions. Do your best to answer them. Keep your answers concise, okay? It's just, they can be 1 sentence even if you want, okay? They don't have to be paragraphs. And just see if you can answer these 3 questions. So I'll just show you what I mean real quick by making a testing main file. And then that will bring this video to a close. And of course, I hope that this video is helpful to you guys. I know it's maybe a little long, but you guys can always skip ahead. I'm sure plenty of you guys have done that already. So what I'm talking about here is you'll probably make a new CPP file. And we'll call it just main test.cpp. So I'll bring that in here. So now we've got this blank file. And what I want you to do is I want you to bring in card.cpp. So if I go look into player H, you'll notice here that I've got that here. So I'll just bring it into my main test. I'll probably also need maybe an IO stream. So I'll bring that in here. Just like that. We'll probably need a namespace. And then an int main, we can test our decks, okay? So the first thing I'd recommend doing is maybe going into the actual main file here and copying this nice bit of code here. I'll even zoom out a little bit. So there it is. We've got a deck dealing deck, and here this will deal out 52 cards for a normal deck. And so then once you're here, go ahead and maybe try dealing deck dot print deck and start with that. And then when you're ready to move on from that, go ahead and try maybe dealing deck. I mean, you could make a deck, new deck, and then you can say new deck is equal to dealing deck, right? And that will do your assignment operator. And then if you wanted to test your copy constructor, then you could say new deck 2 and pass it in the dealing deck to make sure that that works. You'll probably want to print them out. And then from there, you can then say, you know, shuffle. You can say sort, not short, but sort, so on and so forth. And so then you'll just kind of test out everything in this main file. And once you know everything works, then you can go ahead and run the rest of the program. So that's it for this assignment. I know it's quite a lot of pages, but I just try to be very descriptive with everything you need to know. In terms of the actual code, it should be pretty manageable, in which you only have to put some code in some of these functions here. And most of these functions should be pretty small, except when you get to things like the assignment operator overload and perhaps the swap cards portion here. And so that's that. Thank you for watching this video, and I hope you guys have a good time with this assignment.